Alright, so welcome to this short video where we're going to solve a problem that I didn't have time to do in class that involves a subsidy. So the setup is that we're told glasses are subsidized in the US, blah blah blah. There's a whole bunch of basically unimportant stuff in this first paragraph. Then we're told to write an expression that relates PC and PP when there's a subsidy of $3, then solve for equilibrium with and without the subsidy using these two equations. So what I want to do here is do what the question asks in terms of the algebra, but at the same time I want to connect that to the geometry. So I'm going to draw a nice little diagram here, label my Q, label my P. If I was being good, I'd put the units here, but I'm lazy, so I won't. Now I'll draw in the demand curve, just a generic demand curve, downward sloping, don't really care about whether the slope looks good or whatnot. Drawing my generic supply curve. And then what we're going to do is, as we solve this problem and get numbers, we'll plug them in and label this graph. So I know there's this initial equilibrium here that involves some price and quantity, but I don't know what they are yet, so I won't label them. All right, so the first thing we can do is do without the subsidy. So I'll call that without S, and we'll set QS equals QD. We get negative 4 plus 2P equals 20 minus P. You put all the P's on one side, so we have 2P plus P. That gives us 3P. Put all the numbers on the other side, so 20 plus 4 when we bring this 4 over here, right? Bring the 4 over. So that's 24. So we get a price of 8, and then we can plug that price back into either demand here. So demand would give us Q is 20 minus 8 or 12, or we could plug it into supply here. That would give us negative 4 plus 2 times 8, that's 16 minus 4 is 12. So either way we get a quantity of 12. And what I'm going to do is quickly go over here and label the equilibrium price is 8, the equilibrium quantity is 12, and now we can compare this situation to what we get when we solve with the subsidy. Sorry, I put without the subsidy. So with the subsidy. So our starting point will be, it tells us to write an equation that relates PP and PC with the subsidy. So we want to ask ourselves, with this subsidy, with the government chipping in extra money, how much is the producer going to get paid? Well, they'll get paid some amount by the consumer, that's PC, and then on top of that, the government will pay them some money, S dollars. So they'll get PC, oh, no, it erased, sorry. They'll get PC plus the $3. And we'll use this equation to substitute when we set up our QS equals QD. And now remember, with a subsidy or a tax, we're keeping track of the difference between PP and PC. So when I write my QS equals QD, I'm going to have to include these subscripts. So QS equals negative 4 plus 2PP, and that's going to equal QD, that's 20 minus PC. And now I'll replace this PP here, replace this guy with the expression up top, PC plus 3. So negative 4 plus 2, parentheses, PC plus 3, equals 20 minus PC. We'll collect all the PCs on one side, we get 3 PC. Collect all the other terms on the other side, we get 20 plus 4 minus 6. Pause the video if you were having trouble with the algebra. It's really important to practice doing the algebra, write out all the steps. I'm not doing it here because I'm going to run out of space, and I'm all grown up, so I don't need to practice this stuff. But you do, okay? So don't make dumb mistakes on the test. I've seen people write 3 minus 1 equals 1 and lose a lot of points, and that's just, that's not, you don't want to be that person. All right, so 20 plus 4 minus 6. Oh, I erased again. So gives us 18. So then PC is going to be 6. We can stop and ask ourselves if this makes sense. With the subsidy, the consumer only has to pay $6. That's less than the $8 they paid before. That makes sense because the government's paying part of the cost, so they shouldn't have to pay as much as before. That would be strange if they had to pay as much or more. Then we can add the $3 subsidy to get PP. So if the consumer pays the producer $6 and then the government pitches in 3 more, We can plug that into the equation or just intuitively add the 6 and 3 to get 9. Then we can plug PC into the demand curve. Remember, that's way back up here. So we can plug PC of 6 in and get 20 minus 6 is 14. Or we can plug PP into the supply curve. Negative 4 plus 2 times 9 is negative 4 plus 18. That's also 14. So either way, the quantity is 14. That's good because QS should equal QD in equilibrium here. So we can write Q, the new Q, maybe QS is 14. And then let's go ahead and label this on the graph. So we'll have 6 down here, that's PC. 9 up here, that's PC. And 14 is the new equilibrium. And what you see here is that, in effect, the subsidy creates a wedge just like the tax. So this dark line I'm adding, and that's the subsidy wedge. And it separates PP, which is now higher because of the subsidy, and PC, which is now lower because of the subsidy. It's basically the opposite of the tax. With a tax, the wedge would have pushed us to the left over to a point like right here, so there'd be a smaller quantity, and the wedge would have caused PC to be up here, PP to be down here. The subsidy wedge pushes us to the right over here, and PP is now higher and PC is lower, which is the flip of the tax case. So hopefully that helped you to connect the algebra of a subsidy to the geometry, the graphing of a subsidy. If it didn't make sense, I strongly recommend that you basically take this problem and just change the numbers, change the supply curve, make it -2 plus 3p or something, and then solve that one and try to graph it and make sure that it all kind of clicks and makes sense for you. If it still doesn't make sense, send me an email, send me a text, come to office hours, and we'll make it work, okay? All right, see you guys in class.